In this video, we're going to finish up the notes for number 52 with the graphing and converting. In your second video, we're going to move on to some harder converting and going from rectangular to the parametric, which will be number 53. All right, so on this example, we did the converting, but we're just going to take a look at what to do with the calculator. So for graphing purposes, we're starting with t is greater than or equal to 0. Again, you should already have this example written. So I'm going to start with 0 for t, 1 and 2, but we're going to use the calculator to help us. So I'm going to switch screens over to the calculator. Plug both in. So if you hit second ln, that's going to give you the e to the x button. And then for second ln, e to the t. You should follow along with this to make sure your calculator is able to do the same. See if there's any issues that come up that we can address in class. Next thing you're going to want to do is hit second graph. This will bring you to the table. This will give us some values that we want. Now we want to start at t is 0. So notice my first couple get very big very quickly. That's because we're working with something that's exponential. So my first point is -2, 4, and I'm just going to copy the rest of those down. So if you haven't already converted, which we have, you may not recognize that this is a line. You can always go and graph. Give me 2 seconds. So if I hit the graph button here, we're going to do more with graphing later on, but you can kind of see the picture. It's not much, but you are seeing a line going in there. So we're just going to plot 2 of those points, connect them, make it into a line on our sketch. So there will be times where the calculator will be needed to kind of help you with the graphing. Then, as part of this, we had already converted it over to the equation y equals 4x plus 12. But now you want to include the domain and range of this graph. So this graph is going from -2 to infinity, or x is greater than or equal to -2. And the range is greater than or equal to 4. So y is greater than or equal to 4. All right, so that completes that graph. We're going to do one more that's going to involve using trig functions for this video, which will be graphing and converting together. Okay, I'm going to give you a minute to copy those 3 trig identities down. Well, maybe a little less. You can pause it to copy them down if I go a little too fast. The first one, cosine squared plus sine squared is equal to 1. Most of you probably remember that one. The other 2 you will also need for this situation when we go to do converting. So the trig identities are not gone completely. We are going to be using them a little bit in this unit and some trig stuff in future units also throughout this half of the year. Before we do that converting though, we're going to be graphing The x is 3 sine t, y equals 5 cosine t, and a popular format to graph that in is 0 to 2 pi. So we'll include that in there. So for graphing, think about some good t-values that you can pick. If we're going radians, the quadrantal angles are going to be your best bet. So we're going to do 0, pi over 2, pi, and so on. All right, and then you want to think about if you plug 0 in. 0 is 0 for sine and 1 for cosine. So our first one's going to be 0, 5. Our second one, pi over 2, sine of pi over 2 is 1, cosine of pi over 2 is 0. So we're going to end up getting 3, 0. And then this will kind of alternate, except you're going to have some changes in the positive, negative signs. The next one will be 0, negative 5, and then negative 3, 0. And then since 0 and 2 pi are technically the same, it kind of comes back around full circle, or not quite a circle when we go to graph this, but something that we just did in the last unit. So let's take a look at the sketch of this. And you'll notice you end up getting an ellipse if you connect those points. So for converting purposes, we are going to need to understand that our final result will be an ellipse. And we're going to use the trig identities to help us with converting. Now I recognize that you'd probably be able to look at it and see the graph and figure it out, but I am going to ask you to show work for these as well. So first thing we're going to do for converting you want to isolate the trig function, not just the t. So we're going to make this x over 3 is equal to sine t. And y over 5 is cosine t. Then from there, we're going to use the trig identity that says, I'm just going to switch the order, sine squared plus cosine squared is 1. And we can do a nice substitution. Remember, the squared is for the whole function, so I'm going to put in x over 3, square that whole thing. And then, ooh, sorry about that. We do get the standard equation of the ellipse, same as what you're seeing from your graph. Technically, you don't need to do the domain and range, but this is something that you're going to be asked on every converting and graphing question. Because the ellipse, domain, and range actually is what you're seeing, I'm still going to write it. And there you have your two options. You can use inequality or the interval. So that concludes what you're going to need for your graphing and converting. You're going to complete the rest of that graphing packet, the ones you haven't done. The only one you are not going to do a graph for, I think, is number 7, but that'll be written on the work on the Haiku page.